Good morning, dear students. In yesterday period, we were discussed about introductory part of magnetic effect of electric current. Yes, it means what is meant by a magnetic field? It means the space around a magnet in which its effect can be experienced, that is, its force can be detected, is called magnetic field. Afterwards, magnetic field lines. Magnetic field lines means the imaginary lines representing magnetic field around a magnet are known as magnetic field lines. And properties of magnetic field lines. There are totally 4 properties of magnetic field lines. First one, they originated from north pole of a magnet and end at its south pole by convention. Second, these lines are closed and continuous curves. Third, they are crowded near the poles where the magnetic field is stronger and separated far from the poles where the magnetic field is weak. Fourth property, field lines never intersect with each other. If they do, that would mean that there are two directions of the magnetic field at the point of intersection, which is impossible, as these are the properties of magnetic field lines. Afterwards, magnetic field due to a current carrying conductor and magnetic field due to a current through a straight conductor. It means magnetic field B is directly proportional to current I passing through the wire, and magnetic field B inversely proportional to the distance R from the wire. Finally, we get the direction of current in a straight wire is known, then the direction of magnetic field produced by it is obtained by Maxwell's right hand thumb rule. Yes, my dear students, today let us see magnetic field due to a current through a circular loop. Yes, the magnetic field lines due to a circular coil is shown in the given figure. Yes, my dear students, in the given figure. At every point of a current carrying circular loop, the magnetic field is in the form of concentric circle around it. What a concentric circles are around the magnetic field. As we move away from it, the circles would become larger and larger. Yes, my dear students, we move from what a magnetic field. It means a separation straight line N and S. What happen? The circular loop is larger. Circular loop is termed as what? Larger and larger. When we reach the center of the loop, the field appears to be a straight line. Yes, my dear students, in the center, what happen? The loop in the form of what appears to be, the loop appears to be a straight line. A straight line. Yes, my dear students, what happened here? Every point of what a current carrying circular loop, the magnetic field is in the form of a concentric circles. Yes, concentric circle. As we move away from it, what happened? The circles are become larger and larger. Circles are becomes what? Larger and larger. Yes. When we reach the center here, what it appears to be what a straight line. Yes, my dear students, it is the magnetic field due to a current through a circular loop. Yes, the magnetic field produced by current carrying circular loop is a given point. It means it is directly proportional to amount of current flowing through it. First, yes, magnetic field magnetic field B is directly proportional to B is directly proportional to the amount of current I, the amount of current I flowing through it. Yes, my dear students, it means a magnetic field B is directly proportional to what? Current I flowing through it. Yes, it is the first equation of magnetic field due to a current through a circular loop. Yes. Second is magnetic field is directly proportional to number of turns n of the wire. Yes, magnetic field is directly proportional to the number of turns n of the wire. It means B is directly proportional to n. Yes, it is the equation number 2 or equation number 2. Yes, my dear students, this is because the current in each turn is in the same direction. Therefore, the field due to this turn adds up. Thus, the strength of the magnetic field produced by a current carrying circular coil can be increased by what? Increase the number of turns of coil. How the magnetic field produced by a current carrying circular coil can be increased? Yes, it is increased by increasing the number of turns of the coil. Yes. Second, increasing the current flowing through the coil. Increasing the current flowing through the coil. Yes, my dear students, let us observe one second. What a magnetic field produced by a current carrying circular loop. It means magnetic field is directly proportional to the amount of current I flowing through it. It means B is directly proportional to I. Yes. Second, magnetic field is directly proportional to a number of turns. It means n of the wire. B is directly proportional to n. It means number of turns of a wire. Here, what a current flowing through, amount of current flowing through. Magnetic field is directly proportional to current flowing. Here, magnetic field is directly proportional to what? The number of turns of the wire. What it increase? It means what magnetic field increase? Magnetic field is increasing the number of turns of the coil and increasing the number of current flowing through the coil. Yes, my dear students. After discussing about magnetic field due to current through a circular loop, let us see magnetic field due to current in solenoid. Magnetic field due to current in a solenoid. Yes. First of all, a solenoid is defined as a coil consisting of large number of circular turns of insulated copper wire. These turns are wrapped closely to form a cylinder. Yes, my dear students. First of all, what is meant by solenoid? Solenoid is termed as what? A coil consisting of large number of circular turns. Yes, it is defined as, it means solenoid is defined as a coil consisting of a large number of circular turns of insulated copper wire. These turns are wrapped closely to form a cylinder. Yes, my dear students, observe here figure. Yes, solenoid is defined as what? A coil consisting of number of circular turns. Yes, my dear students, it means it is an copper wire. Which wire? Copper wire. Means copper wire is wrapped closely to form a cylinder. It is termed as what? A solenoid. The field lines around a current carrying solenoid are similar to that produced by a bar magnet. This means a current carrying solenoid behave as if it has north pole and south pole. The field line inside the solenoid are parallel to each other. Yes, my dear students, here field lines are parallel to each other, where in a solenoid field lines are parallel to each other. Thus, the strength of magnetic field is the same at all points inside a solenoid. Yes, my dear students, but just if people are remember here what is meant by a magnetic field in a solenoid. Yes, it is defined as a coil consisting of a large number of circular turns of insulated copper wire. These turns are wrapped closely to form a cylinder. Yes, and also a current carrying solenoid behaves as if it has north and south pole. The field line inside the solenoid are parallel to each other. Thus, the strength of magnetic field is the same at all points inside the solenoid. Yes, my students, after discussing about solenoid, let us see electromagnet. Yes, the strong magnetic field produced inside the solenoid can be used to magnetize a piece of magnetic material like soft iron when placed inside the coil. Yes, my dear students, here soft iron is placed where? Is placed inside the coil. Yes, inside the coil. Soft iron is placed inside a coil. Which coil? A coil of wire. It means copper wire connected to a battery. Yes, my dear students, observe here. The magnet so formed is called electromagnet. Yes, what is the electromagnet or electromagnet means? Electromagnet means the strong magnetic field produced inside a solenoid can be used to magnetize a piece of magnetic material like soft iron when placed inside the coil the magnet so formed is called electromagnet. Yes, observe here. The strong magnetic field produced inside a solenoid can be used to magnetize a piece of magnetic material like soft iron when placed inside the coil. The magnet so formed is called electromagnet. Yes, my dear students, here soft iron is taken as example is yes placed inside a copper wire. Yes, my dear students, what is formed here? Electromagnet. An electromagnet is used in electric bells, electric motors, telephone and loudspeaker and for sorting scrap metals. Yes, my dear students, where electromagnet is used. Yes, electromagnet is used where used in electric bells, electric bells, electric motors, and loudspeakers Yes, my dear students, these are the uses of electromagnet. Yes, let us see. Force on a current carrying conductor in magnetic field. Force on a current carrying conductor in a magnetic field, magnetic field. Yes. When a current carrying conductor is placed in a magnetic field, it experiences a force except when it is placed parallel to the magnetic field. The force acting on a current carrying conductor in a magnetic field is due to interaction between magnetic field produced by a current carrying conductor and external magnetic field. When it experienced interaction between a magnetic field is produced by the current carrying conductor and external magnetic field in which the conductor is placed. It means it defines what? It defines first one, direction of current. It defines direction of current, and second one direction of magnetic field. Direction of magnetic field. Yes, my dear students, direction of current means the direction of force on conductor can be reversed by reversing the direction of current. When the direction of force on the conductor can be reversed by reversing the direction of current, Yes, it defines first a direction of current. It means a direction of force on the conductor can be reversed. What happened? The reversing direction of the current will be takes place. And second one, direction of the magnetic field. It means the direction of force on the conductor can be reversed by reversing the direction of magnetic field by interchanging the position of poles. Yes, my dear students, force on a current carrying conductor in a magnetic field, it defines what? It defines first one, direction of current, and second one, direction of a magnetic field. Direction of current means a direction of force on the conductor can be reversed by reversing the direction of current. Yes, how? The direction of magnetic field defined? Yes, direction of force on the conductor can be reversed by reversing the direction of magnetic field by interchanging the position of poles. Yes, my dear students, all of you already know there are totally 2 poles. How many poles? 2 poles. Yes, north pole as well as south pole. Yes, interchanging of poles, what happen? A direction of magnetic field will be changed. Yes, my dear students, after discussing about force on a current carrying conductor in magnetic field, let us see Fleming's left hand rule. Yes, first of all, Fleming's left hand rule indicates what? Here 3 fingers, thumb finger, index finger and middle finger. Here each finger can shows what? a different directions, a different direction. Yes, the direction of force which acts on a current carrying conductor placed in a magnetic field is given by Fleming's left hand rule. It means it states that if the forefinger, thumb finger and middle finger of left hand are stretched mutually perpendicular to each other such that forefinger points along the direction of external magnetic field and middle finger indicates the direction of current, then the thumb points towards the direction of force acting on the conductor. Yes, my dear students. Yes, here thumb indicates what? Thumb indicates force on the conductor and index finger indicates direction of the magnetic field, and third one middle finger it indicates what? The direction of current. Yes, force on the conductor is thumb finger, it indicates what? A force, thumb finger indicates force on the conductor and index finger indicates direction of magnetic field, and third middle finger indicates direction of the current. Yes, Fleming's left hand rule. Okay, rule, it states that if the forefinger comma thumb comma middle finger of left hand are stretched mutually perpendicular to each other such that the forefinger points along the direction of magnetic field, middle finger indicates direction of current, then the thumb points towards the direction of force acting on the force acting on the conductor. Yes, my dear students, let us once again see here. Fleming's left hand thumb rule states that if a forefinger, middle finger and thumb are stretched mutually perpendicular to each other. Yes, here index or forefinger indicates what? The direction of magnetic field. Yes, middle finger indicates direction of the current and a thumb indicates force on the conductor. This is the Fleming's left hand thumb rule. Yes, my dear students, in today's period we all are discussed about what is mean by a magnetic field due to a current through a circular loop. It means how circular loops are produced in a magnetic field. It means magnetic field is directly proportional to current time and magnetic field B is directly proportional number of turns of the wire. Yes, afterwards solenoid. Solenoid is defined as what? A coil consisting of large number of circular turns of insulated copper wire. These turns are wrapped closely to form a cylinder. Here each field lines are parallel to each other. Afterwards electromagnet, soft iron, copper wire and battery. Here how electromagnets are formed and where electromagnets are used we discussed. Afterwards, in which factor a force on current carrying conductor in a magnetic field defines. Finally, Fleming's left hand thumb rule. Yes.